So we're going to be solving problems using logarithms. So we're going to be talking about the pH scale. So the pH scale is a measure of the relative acidity in moles per liter compared with neutral water, which has a pH of 7. So the scale ranges from 0 to 14, and 7 is neutral. So there are 3 formulas, but they're literally the same thing, just written in different ways. We're going to be using this formula today because personally I feel like it's easier and it gives you the exact same answer. So let's see the first question. A hydrogen ion concentration in a juice bottle is this moles per liter. What is the pH level? So we're going to plug this into our equation. So pH equals negative log of that 4.67 times 10 to the exponent negative 2. So we can plug this whole thing into our calculator and we will get negative log 4.67 times 10 to the exponent negative 2. 1.33. So therefore our pH level is 1.33. Let's look at our second question. So a bottle of vinegar has a pH level of 2.5. What is the hydrogen ion concentrate? So this is basically the same thing, but the rules are reversed. We have the pH level and we're trying to get the hydrogen ion concentrate. So we're going to plug this into our equation. So 2.5 equals negative log H positive. Okay. We don't want a negative log, so we can divide both sides by negative 1. So this becomes negative 2.5 equals log, of this. So we want to cancel log, so we're going to use log base 10. So remove log, use log base 10. So 10 to the exponent of log negative 2.5 equals 10 log. Everything becomes an exponent. So this and this. So this becomes 10 negative 2.5 equals. So this is our hydrogen ion concentrate. If you want, you can put it in scientific notation. Okay. So let's look at our second and third example, which is over here. Actually, let's close my laptop. Okay, so sound levels are measured in decibels. Okay, so sound level that's greater than 85 decibels will damage your ears. The minimum intensity detectable by the human ear is IO equals 10 to the exponent of negative 12. So the formula for sound levels is this. But we're going to plug in IO as 10 to the exponent negative 12. So it becomes this. So let's look at our first example. What is the sound level of a classroom with an intensity of 82? So they want L. Let's write down our equation first. L equals 10 log I over so we can easily solve this. So we have an intensity of 82 and we want the sound level. So we're going to plug in 82 into our equation. 10 log 82 over 10 negative 12. We can rewrite this as L equals 10 log 82 times 10 to the exponent of 12, since we're changing the sign. Since we're doing the opposite, so we change the sign. We can plug this into our calculator and we get, let's see, 10. So look, this is 10 multiplied by the log of this times. So make sure you put that into your calculator. Make sure you put a bracket between 10 and log of 82 times 10 to the power of 2. So we get 139.14 rounded. So therefore, the sound level of a class room with an intensity of 80 is 139.14. So let's look at our third and final question. How much louder is the classroom? So how much more intense is a classroom compared to a normal conversation of about 46 dB? So they're giving it to us in decibels. So we're going to have to find the intensity of a normal conversation. So we're going to plug 46 into our equation. So 46 equals 10 log I over 10 to the power of negative 12. So we can divide this by 10 and this by 10. Okay, we can simplify this to 23 over 5 equals log of I over 10 negative 12. So we want to remove log. So we're going to use log base 10. So 10 23 over 5 equals log I over 10. So 10 to the exponent of 23 over 5 equals I divided by 10 to the exponent negative 12. So we're trying to solve for I. So we're going to multiply both sides by 10 to the power of negative 12. So 10 to the power of 23 over 5 times 10 to the power of negative 12 equals I. So using exponential laws, when we're multiplying two terms with the same base, we add the exponents. So 23 divided by 5 plus negative 12 gives us negative 7.4. So we have the intensity of a normal conversation, which is negative 7.4. And we also have the intensity of a loud classroom, which is 82. Oh, I made a mistake here. This is supposed to be 10 to the exponent of negative 7.4. So, to see how much more intense a classroom is to a normal conversation, we're gonna have to see 10 to the exponent negative 7.4 times what gives us 82. So what we can do is divide 82 by 10 to the exponent of negative 7.4. 82 divided by 10 to the exponent negative 7.4, which gives us this value. Therefore, a classroom is times more intense than a normal conversation.